So solving chemical problems. We're going to have a lot of word problems to solve in Chem 1A. Many of them amount to unit conversion problems. And the best approach for unit conversion problems is using a process called dimensional analysis. I learned this when I was a junior in high school in physics class, and it's probably the most important thing I learned in high school. The most useful thing I learned in all of high school was dimensional analysis, how to mess around with units. It's amazing what you can figure out just from the units. So, very important, we should always include units in your calculations. They get multiplied, divided, canceled, just like any other algebraic quantity, like the x's and y's. They'll cancel out, they'll multiply, and you can square or cube them. They act just like a variable. So a unit equation is a statement of two equivalent quantities. Here's an example. 2.54 centimeters equals 1 inch. These are two quantities that are equal. They both represent the same length, just one is expressed in inches, another is expressed in centimeters. We can make a conversion factor from a unit equation. And I always forget what's on the next slide, so sometimes I jump ahead, but that's okay. So what we can do is we'll take 2.54 centimeters is equal to 1 inch. So those things are equal, and if we have an equality and we do the same thing to both sides, it's still equal. So if I divide both sides by 1 inch, this is still equal because I did the same thing to both sides. What is 1 inch over 1 inch? It's 1, because anything divided by itself is 1. So that is equal to 1. So 24 centimeters over 1 inch is equal to 1. It doesn't look like 1. It looks like 2.54. But it's centimeters per inch. If we multiply something by this, are we changing its size? No, we're just changing the unit. And that's the basic idea of dimensional analysis. We're multiplying by factors that equal 1, and we're just changing the units. We're not changing the thing that the measurement. So most of these problems are going to take this general form. They're going to give you some information. You'll have a given unit. You're going to multiply by a conversion factor, and then you're going to get the desired unit. They're going to say, well, here, this is 12 inches. How many centimeters is it? So you have a given unit and a desired unit. We multiply by the desired unit, we divide by the given unit, and then the given unit cancels out. Let's do a quick example in there. Let's do 31 miles, and let's convert that to feet. It's about 31 miles from my house to Fresno City College. What's the relationship between miles and feet? 1 mile, 5,280 feet. Some of us remember that. I don't expect you to remember that. A mile is 5,280 feet. You can always look that up. That's the relationship between. So we could make two different conversion factors from that. We can say 1 mile per 5,280 feet, or we can upside down it, invert it, 5,280 feet per 1 mile. Both of those are equal to 1 because the top equals the bottom. A distance of 5,280 feet is the same as the distance of 1 mile. Okay? Notice that we have to keep the 5,280 with the feet. We can't say that 1 foot is 5,280 miles because that's ridiculous, isn't it? A foot is just really short and a mile is long. So we can take this and apply it to our 31 miles and convert it into feet. So our path we have a little path here. We're starting here and we're going there. And we're going to multiply by a conversion factor. These are the units that we want in the numerator, miles to feet. And then we want to get rid of miles, so we need to divide by miles. So we divide by miles down there. The miles cancel out. Dimensional analysis, you're analyzing the dimensions, the units. The units tell you where to put the numbers. It takes a lot of the thinking out. So now we just look at this relationship, and 1 and mile go together. So we put 1 with mile, and we put 5,280 with feet. And then we do the math, 31 times 5,280. That's a lot of feet. 163,680 is what my calculator tells me. So is it 163,680 feet exactly from here to my house? No, because I'm kind of estimating this 31 miles. That's to the nearest mile, right? So there could be a wide variation in number of feet. Sig figs. How many sig figs in 31 miles? 2. Just because it's a whole number doesn't mean it's exact. So 2 sig figs in 31. How about this guy? That's unlimited. That's an exact number. Miles and feet are in the metric system? No, they're in the English system. And that's defined. So those are exact. But our answer then will be limited to 2 significant figures. Is it 16 feet? That would sure be a nice commute. It's 16 feet. I think it's more than 16 feet to my office. Right? We can't do that. Scientific notation. 1.6 times 10 to the 1, 2, 3, 4, 5. 1.6 times 10 to the 5th feet. Some of your calculators, like the TI-30XA, allows you to convert back and forth between scientific notation just by pressing a couple buttons. And so, yes? Oh, I'm sorry.
I was going to ask, on the test, do we have to memorize how many feet are in a mile?
No. I will tell you the things that you are supposed to memorize. I think you should memorize 1 inch is 2.54 centimeters. And you need to memorize the metric prefixes. But other things, if you need them, I will give them to you. Yeah, and if you raise your hand and I don't happen to see you, make a noise, please, because I get distracted. So any questions about that? So what happens when we have units raised to a power, like when we have an area or a volume? Then we have to be careful. So we know that 2.54 centimeters is equal to 1 inch. But what's the relationship between square centimeters and square inches? Well, so that's not what I was trying to do. Here's a box. Okay, and this is a square, and it is 1 inch on each side. So the area then is 1 square inch, right? We can also measure this as 2.54 centimeters, same length, right? So if this is a square, it's not quite a square, we're pretending it's a square, 2.54 centimeters, then the area is going to be 2.54 square centimeters. Right? Because it's 2.54 centimeters times 2.54 centimeters. So developing a relationship for a unit raised to a power, you start with the base unit, centimeters and inches here, and the relationship between them. And then you have to square the whole thing. You square the unit and the number. So here the unit's being squared, the number has to be squared too. And the number squared would be 6.45. That looks like they rounded it because I doubt that that's exactly 6.45, although maybe it is. You don't want to round things though. But that's 6.45 square centimeters is 1 square inch. So let's do some examples. There are 2.60 times 10 to the 15 short tons of oxygen in the atmosphere. A short ton is 2,000 pounds. How many metric tons of oxygen are present? A metric ton is 1,000 kilograms. So here is a word problem, and we've got some numbers in here. These guys in parentheses, something equals something, those are conversion factors, unit equations, information. There's really only one number that's given in this problem, and that's a number of short tons of oxygen. So we have to identify the number we're starting with and its unit and what unit we're trying to find. So I'm going to write this down over here, 2.60 times 10 to the 15 short tons. And what are they asking us for? How many metric tons? So then over here, we want metric tons. These problems always remind me of Dora the Explorer. You seen Dora? She's got a big head, doesn't she? Anyway, she's kind of cute. She's got a really big head. But Dora's always trying to get somewhere. And who does she call when she doesn't know which way to go? Backpack. And in the backpack is the map, right? So we call map when we don't know where to go. So the map tells us, I'm at the rushing river and I need to go over the bridge and through the tunnel and then I'll get to the snowy mountains. And then they say, over the bridge, through the tunnel, to the snowy mountains. And they chant it like 5 times so that the little kids can remember this. So here we are at short tons and we have to figure out how to get to metric tons. Oftentimes there's more than one path, just like there's more than one way to get from Reedley to Fresno. I'm just kind of exploring the different ones because it gets boring doing the same one over and over again. But there's different ways. But sometimes there's an easier way and there's a harder way. The hard way to get to Fresno would be to go around the other side of the earth and go all the way around and approach it from the north, right? That would be hard. So we want to avoid hard. But whether you take Kings Canyon or 99, it's roughly the same. So you may be working with a friend and they may have a little different path. It's okay. There's multiple ways. Sometimes, like in this example, they're providing you with some information and then usually you might want to use that. So here we have a relationship between short tons and pounds. So we're starting with short tons. Using the relationship that was given, we could get to pounds. And then they gave us this other relationship, and we look at that and we're like, well, that doesn't have pounds in it. So we kind of got to a dead end there. Well, then start at the end and work backwards and see if you can find something that meets up in the middle. This gives us information about metric tons and kilograms. So if we had kilograms, we could find metric tons. Is there a convenient relationship between pounds and kilograms? There is. You may have to look it up, but there is one. For each of these steps, we need to know the relationship between those units. So I think this is right. I think this relationship is 2.206 pounds is equal to 1 kilogram. Does anybody have a chart that can confirm that? 0.5. That's pretty good. So 2.205 pounds is equal to 1 kilogram. Now we have all the information we need to do this problem. So we write down our starting number, 2.60 times 10 to the 15. I'm going to call that ST because it's too long. This is our map. This tells us what to do. If you're really good at dimensional analysis, you don't have to write down the map. If you're struggling with dimensional analysis and unit conversions, write down the map. So We look at the map, we have 1, 2, 3 arrows. We're going to have 3 fractions. And then we pretend that we're Dora. Short tons, pounds, kilograms, metric tons. And then we go down here, short tons, pounds, kilograms, metric tons. Exact same thing. Pounds, kilograms, we'll call that MT, metric tons. That's the path. We want to get rid of short tons, so we divide by it. It cancels out. We've got pounds, we want to get rid of it, we divide by it. Cancels out. We've got kilograms, we're going to divide by it to make it go away. The unit we're left with, metric tons, is what we're trying to find. We've analyzed the dimensions. We've looked at the units. The units tell us then where to put the numbers. So we get all the units in first, and now we go looking for relationships. So here we need the relationship between pounds and short tons. Well, that's right here. 1 short ton, 2,000 pounds. So 2,000 pounds is 1 short ton. The middle one, kilograms and pounds. 1 kilogram, 2.205 pounds. You can't switch the numbers just because you'd rather multiply. Metric tons, 1 metric ton, 1,000 kilograms. It's good to be systematic about punching this through in your calculator. So I recommend that you start at the left and go to the right, just like when we're reading, and go top and bottom, top and bottom, top and bottom. So 2.6 EE15 times 2,000, you can divide by 1 if it makes you feel better, and you can multiply by 1 if it makes you feel better. Divided by 2.205 times 1 if you want to, divided by 1,000. So let's see if I can do that. 2.6 EE15 times 2,000 divided by 2.205 divided by 1,000 and I get 2.35827666415 is what my calculator is showing me. This is calculator language. We don't write calculator language on paper. You need to convert it to human math language, and that little exponent means times 10 to the 15. And then I want to write the unit. I abbreviated it metric ton. Is this an exact conversion? Yes. Is this one? No. Pounds is English, kilograms is metric. Is this an exact conversion? Yeah, because this is all metric. So here, this one has 4 sig figs, and how many does our starting number have? 3. So then we're going to give our answer as 2.36 times 10 to the 15 metric tons. Any questions? Truly understanding dimensional analysis is very, very, very important for being successful in Chem 1A. Significant figures are important, but you can get by fudging through those most of the time. But you're going to really struggle if you don't get dimensional analysis. And we're going to do a worksheet during lab, and so if you need help with this, please ask me. Let me see what kind of examples I have in here. I don't necessarily want to do all of these, because, wow, there's so many of them.
Skip right over the space shuttle.
I'll get to that one's at the end. We'll get to the space shuttle one. I wanted to do at least one with a unit raised to a power, and so that'll be this one. And then I want to do one that's just kind of weird. So let's do this one. The area of a telescope lens is 7,903 square millimeters. What is the area in square feet? So here we have our number. There's only one number given to us. So this is our beginning unit, and we're trying to find square feet. So we've got 7,903 square millimeters, and we're trying to get to square feet. Do you know the relationship between millimeters and feet off the top of your head? I don't. These are squared units, and so what we do with the squared units is first ignore the square part and think about a path to do without the square, and then we'll put the square in afterwards. Well, here we've got English on the right and metric on the left. What relationship, what's going to be one of our middle steps, do you think? Let's try to just use what we know. We know centimeters to inches, right? So if we got inches in here, we also know inches to feet. So if we got centimeters in there, do we know the relationship between centimeters and millimeters? $10 millimeters is a centimeter. Okay, how many people does that really make sense to? But over half the class. Okay, we'll go with that. There's a different way to do that calculation, but I'm not going to focus on that now. So there's 10 millimeters in 1 centimeter. You always look at a ruler, and there's 10. The little lines are millimeters, and there's 10 of them. So we're going to go millimeters squared to centimeters squared to inches squared to feet squared. But we're going to ignore the square at first. So we've got 7,903 millimeters, and we're going to have how many fractions? 3, because we have 3 arrows. Millimeters to centimeters to inches to feet. Millimeters to centimeters to inches to feet. Millimeters to centimeters. She often goes to the snowy mountains. So then my kids were always, are those the snowy mountains? Well, right now they're not snowy, but. So we put those in, going across, and then the previous unit comes down here because we want it to go away. So we want those to cancel out. Centimeters. Do you see this pattern that I'm doing? You learn this pattern, you can do all kinds of things with any sort of unit. Your dog needs worm medicine, or the cow needs a shot of something. You can do this with the units on the medicine, and you can figure out how much to give the animal or the child. It's awesome. So we got all those taken care of. Numbers in now. We decided that there were 10 millimeters in 1 centimeter, and we remember that 1 inch is 2.54 centimeters, and feet to inches, 1 foot and 12 inches, right? Really important to get the numbers in the right place. You don't want to say 12 feet is 1 inch. Now, when we square the units, this was actually millimeters squared. Now, when you have a number like this, they're saying 7,903 millimeters squared. That square just applies to the millimeter. Do not square the 7,903. Don't do it. Some people get really carried away with the whole squaring business. Here, this is the relationship between centimeters and millimeters. And so to get squares on those units, we square the whole term. And we square this whole term, and you square this whole term. Because we're squaring the units and the numbers. Is everybody with me? Yes or no? Yeah, okay. Now, how you get this into your calculator is really a matter of personal preference. I would use the x squared button on my calculator. And I would I would do 7903 divided by 10 squared, divided by 2.54 squared, divided by 12 squared equals, and I would get an answer. So if you and your calculator are really on the same wavelength, that's awesome. If you're not, go ahead and square these numbers separately and write the equation out again. So I'm going to do that. 7903 millimeters squared times, now when I square the number on the top, 1 times 1 is 1. So that's 1 square centimeter. On the bottom, 10 squared is 100 millimeters squared. Then over here, the top is 1 inch. The whole thing squared, 1 squared is still 1 inch squared. On the bottom, I need to do 2.54 squared, which is 6.4516 square centimeters. And then over here, I'm having 1 square foot and 144 square inches, because 12 squared is 144. Units are canceling. But now there's not quite as much thinking involved. 7903, no, 7903 divided by 100 divided by 6.4516 divided by 144 equals 0.085067184 square feet. Is that number at all reasonable? Yeah, it is. Because a square millimeter is a little teeny tiny thing, right? And a square foot is bigger than a piece of paper. So we expect the smaller unit to have the bigger number and the bigger unit to have the smaller number. That's what we call the bigger, smaller rule. How many sig figs should that answer have? 4. This is exact within the metric system. This is exact because it's defined that way. This is also exact. So those are not going to affect the number of sig figs. We started with 4, we'll end with 4, and so we'll call this 0.08507, 4 sig figs square feet. Any questions? Yes?
If you want to do the whole equation on a calculator, how do we do it again?
Okay, I'll talk you through that. So 7903 divided by, I don't multiply by ones, but you can do it if you want to, divided by 10, and then I press the x squared button. And then I would multiply by 1, divide by 2.54 x squared, divide by 12 x squared equals, and I get the same answer. Any other questions? Yes?
I think you were saying it's 8.502 to the negative 4.
It would be 8.507 times 10 to the minus 2. Because if we're going to put that in scientific notation, which is a good question, we're going to take the decimal point 1, 2 places. We always put the decimal point beyond the first non-zero digit, and so I only had to move it 2 places. So I'll just write that up here because I ran out of space down there. It would be 8.507 times 10 to the minus 2 square feet. In my opinion, it's never incorrect to write your answer in scientific notation, like on a lab or a worksheet or anything, unless it's saying, take this scientific notation number and put it into decimal form. Scientific notation is always fine. If I have to mentally count the number of zeros, either at the end of the number or at the beginning of the number, I think scientific notation is a great idea, because I don't like pointing and counting, and I can't seem to track well enough to count like 7 zeros. I get lost. It's frustrating. I have to get out the pencil. If a question asks for the answer in scientific notation, then you have to put it in scientific notation. I'm not going to do the second part of that. We'll do part of this one. Do you want to do kilometers per hour or miles per minute?
Miles a minute.
Miles per minute. Okay, so we'll do the second part of this question. Oh, and just to let you know, one of my pet peeves, sometimes there's questions that ask for 2 answers, or they have 2 parts. And students often will answer the first part and ignore the second part. I hate that, okay? And if you go filling out job applications or something, or writing reports for your boss, and he says, what's this and this? Yeah, he's not going to like it either. So if it says, what is the speed in this and that, then we have to do both, except that I'm the teacher and I'm changing the question. Okay, so I'm saying, no, we're not doing that, we're just doing this one. So here's our number, and there's our unit, meters per second. We have to be precise when we write our units. M is meter, MI is mile. Okay, sometimes people, because we can't use M for mile, minute, mole, and meter. It just doesn't work. It's very confusing. So we've got 2.998, so easy to mess those up, times 10 to the 8th. This is a horizontal fraction with a slash in it. Write it vertically so that you see that that's a fraction. And then might as well just go all the way across with that line. That's meters over seconds. The unit they're asking for here is miles per minute. So I'm going to write that over here, miles over minute. Because somehow when you do the slash, it just doesn't jump out at you as a fraction. You have to recognize that it's a fraction. Here we're converting 2 things, the numerator and the denominator. And you can't do them at the same time. You have to do one and then the other, because you can only change one thing at a time. So let's first think about the top. How do we get meters to miles? Do we know a relationship between meters and miles? What is it? We could do that. We could go, we know an inch to centimeter, and we could do meters to centimeters to inches to feet to miles. We could definitely do that. I don't feel like doing that right now. Do you? That's a lot of steps, huh? Pardon me? 1,600 meters in a mile. So we can look things up. 1,600 meters is equal to 1 mile. I think that's definitely not an exact conversion. I think if we look it up, we'd find that there's like a 7 or something there. But we can just use that. If you're using something, write down what you used. Okay? Don't just, oh, I pulled this out of nowhere. Write down what you used. So that's a relationship between meters and miles. So we can go from meters directly to miles. How about seconds to minutes? We could do that directly too. So look, I left all that space for nothing. What's the relationship between minutes and seconds? 60 seconds equals 1 minute. Not 1 mile. But I have 2 arrows here, don't I? I have meters to miles, and I have seconds to minutes. So I do need 2 fractions. 2.998 times 10 to the 8th meters over seconds. So let's go to miles first. We multiply by miles, then we want to divide by meters, so the meters cancel out. And then we're going to have another factor here. So we already took care of the numerator. Now we're looking for the denominator. We want minutes in the denominator. So I want to write minutes down here. And then I want to put seconds up here, because this part of the conversion is almost like we're doing everything upside down, because we've got a number down in the basement in the denominator. So now we're multiplying by what we want to get rid of and dividing by what we want. But the result is that we end up with miles per minute. So now we know there are 60 seconds in a minute, and 1 mile is 1,600 meters. So on the calculator, 2.998 EE8. Do not type in times 10. You'll mess everything up. So 2.998 times 10 to the 8th is 2.998 EE8 divided by 1,600 times 60 equals. Big number. 11242500 miles per minute. That's pretty fast. It's a lot faster than 70 miles an hour, that's for sure. Okay, how many sig figs should that have? Why 4? This number has 4. What about that conversion factor? It only has 2. Meters is metric, miles is English. Okay, and the way this is written, those are ambiguous zeros. Do we know the relationship between meters and miles more carefully? Yeah, we can find a better estimate for it. But that's what we used. So then that's going to limit our answer. So is this the best choice of a conversion factor? No, because we're going to lose some of our significant figures because of it. But if that's all we have, that's all we have, and we'll do it anyway. So is that 11 minutes, miles per minute? No. That's ridiculous, right? Question?
Yeah, if you would have went the whole 7 meters in like the whole long way for the answer, you wouldn't have the same result.
We would have more significant figures. We keep our 4 sig figs.
Oh, then you put that in reference for that reason.
Right.
Okay.
Yeah. So, someone proposed this, which is very close. Let me look real quick. Come on, thumb. Oh, wrong place. Sorry, YouTube people. Miles, 1 mile. Come on. 1. Great. 1 mile. Metric. Kilometers. 1.609344. 1.60934 kilometers is 1 mile. Now that's not exact either, but that's got a whole bunch of significant figures. So that would be equal to what? 1,609.344 meters. So if we used that, we'd have 4 sig figs. But because we use this one, we don't. So it'll end up being 1.1 times 10. And we're going 1, 2, 3, 4, 5, 6, 7 times 10 to the 7 miles per minute. Any questions? Pardon me? Oh, thank you. Missing an N. Miles per mile. Bleh. Sometimes my decimal points look like commas because otherwise they get to be too small, like this one's kind of on the small side. Scientists rarely use commas because if we have a big number, you know, millions or billions, that's so large that we want commas so that we can see how big it is, we use scientific notation instead. So, oh, I'm going to do this one too, just because this illustrates converting metric unit where both of them have prefixes. Average radius of a molecule of lysozyme, an enzyme in tears, do we need that? No, we don't, is 1,430 picometers. What is the radius in nanometers? So 1,430 picometers, and they're asking us to find nanometers. The most straightforward way to do this is to go to meters in the middle. So look at your units when you're doing metric conversions. There's one prefix here and there's one prefix there. I have two prefixes. I should do 2 steps. Can you do it without? Yeah, you can. We did centimeters and millimeters without going through meters. That one's pretty easy. But this one, you're likely to get it wrong. I wouldn't do it. I would just whip it out and go through meters. I just think it's better. So 1430 picometers. We see we have 2 arrows, we have 2 fractions. Picometers to meters to nanometers, says Dora. Picometers to meters to nanometers. We're going to put the previous unit down here because we want them to cancel out. We're going to put meter down here because we want it to cancel out. And we're left with nanometers, which is what we want. To put the numbers in here, all we have to know is the numerical meaning of the metric prefix. Let's start with nano. What does nano mean? 10 to the negative 9. Nano and 9 sound a lot alike. So this is 10 to the minus 9. Remember what pico is? Negative 12. We didn't have to look anything up. Nice. All we have to do is remember the 10 to the whatever for the metric prefix. Now, on your calculator, how do you put in 10 to the minus 12? Pretend it's in scientific notation. 1 times 10 to the minus 12 is the same as 10 to the minus 12. So 1430 times 1 EE minus 12 divided by 1 EE minus 9 equals 1.43 nanometers. This number had 3 sig figs. That number has 3 sig figs. Yes?
Isn't like the point of the metric system that when they're both the same unit and it's just different prefixes, you can do it like instantly?
You can do it very quickly if you understand what to do with the exponents. Yeah. So when you have 10 to the minus 12 and you're dividing by 10 to the minus 9, you can add or subtract exponents as appropriate. If you're dividing, you're going to take this one and you're going to subtract the one that you're dividing by. So minus 12 minus a minus 9 is minus 3. And so then you've got 1430 times 10 to the minus third. You're just moving the decimal point over 3 places and you get 1.43. So for those of you that have that sort of a mind, you understood that, awesome, you can do that. Yeah, most metric conversions, if you understand how to do that, you can do it in your head. You don't need a calculator. If that didn't make any sense to you, do it like this and punch it through on your calculator. It'll take you like 5 seconds longer and you'll still get the right answer. Any other questions? No, we don't want to do that one. Okay, you guys wanted to do the space shuttle one. You want to do A or B? I think we should do B. B is more interesting. Small hole in the wing of a space shuttle. It needs a 20.7 square centimeter patch. The patching material costs NASA $3.25 per square inch. What's the cost of the patch? You know, this is one of those more involved word problems. We're ignoring part A. We're not doing that. So we've got this number here, and we've got that number there. So let's just write them down and look at them. $3, dollar is a unit, per square inch. Vertical fraction. Here we have a single unit, centimeters squared. Here we have two units with a per, dollars per square inch. 98% of the time, I just made that up, 98% of the time, but a lot of the time, that's going to be used as a conversion factor. That's not the number you're starting with. Because you have these two numbers, and some students have a hard time knowing which one do I start with. Because if you start with the wrong one, you kind of go down this rabbit trail and you get frustrated. So we're going to use this as a conversion factor, and we're going to start with 20.7. So we're going to take 20.7 square centimeters. I guess we need to write a little path over here. Square centimeters, and we want to get to cost, so that would be dollars. This piece of information relates square inches to dollars. So if we knew the square inches, we could figure out the dollars, right? Can we go from square centimeters to square inches? Yeah, we can do that. We learned how to do that. So that's what we're going to do. Square centimeters. And first we're going to ignore the square and just put in the conversion for centimeters to inches. So that's 1 inch and 2.54 centimeters. But then we square the whole thing, including the number, especially that number. Do not square the 20.7. This square refers only to the centimeters. Here, this square is the whole thing. And then next, we need to go, so those guys are going to cancel out. And then we need to go from square inches to dollars. Here we have dollars on the top. We want dollars on the top and square inches on the bottom. So that'll be 3.25 per 1 inch. So 20.7 divided by 2.54 squared times 3.25 equals. How many sig figs should that have? 3. So 10.4. $10 and roughly 40 cents. Any questions? I can pretty much guarantee you that there will be a question on the exam, and probably one on the final too, that just gives you some weird unit combination things that you've never seen before and makes you put them together and solve a problem like this. It's all in the units. It's all in the units.